Alright, in this section, we're going to continue finding greatest common factor, but this time we're going to start the first process of factoring. So, if you remember, I talked about yesterday or the day before, whenever you were viewing the last videos, I talked about how it was the largest number that they share in common, and really what it comes down to is the lowest exponent they share in common. But, like I said, logically, let's go ahead and think about what we're actually doing here. So what I'm going to be talking about is factoring this polynomial, and the only way we know how to factor right now is with the greatest common factor. So what I'm going to do is I'm going to look at my numbers. I'm going to decide the biggest number that they share in common. What number goes into both 4 and 16? The largest number. Well, 4 goes into 4, and so does 4 goes into 16. Then the next thing I'm going to do is figure out the greatest number of y's they share in common. The greatest number of y's they share in common is y to the third. Then what we're going to do is we're going to make a set of parentheses, because actually what we're doing when we're factoring is we're doing like backward distributing. So if I was to distribute this through to this set of parentheses, I would get back to the exact same problem that I just started with. So I'm really now asking myself, I'm going to fill in these blanks. I'm going to fill in a blank here, and then it says minus a blank here. So let's fill in our blanks. 4y cubed times what gives me 4y cubed? Well, that would just simply be a 1. 4 times what gives me 16? 4. Y cubed times what gives me y to the fourth? Well, I need another y. This is the factored answer. You can check all your solutions by distributing it back out. So if you were to distribute this, you would get 4y cubed minus 4 times 4 is 16, y to the third times y is y to the fourth. You get back to where you started. This is the solution that we're looking for, though. Let's try another one of these. Again, we're factoring this polynomial. The only method we know of factoring right now is greatest common factor, so we're looking for the greatest common factor. I have 3 terms. So I know I'm going to start to look at the numbers first. What number do they share in common? Well, 6 doesn't go into 9. So the next smallest factor of 6 would be 3, and 3 goes into each one of those. So I'll say they have a 3 in common. This one has a p, this one has p times p, and this one has p times q. So really the only variables they share in common is a single p. Make a set of parentheses. I had 3 terms to start with, so my parentheses on the inside should have 3 terms as well. Carry down my signs. 3p times what gives me 6p? Well, 3 times 2 gives me 6. I don't need another p because it's already out front. 3 times what gives me 15? Well, that's 5. I need p times what to give me p squared? Well, I needed 2 of those p's, so I need another p here. 3 times what gives me 9? That would be 3. P times what gives me the p? I don't need another p because it's out front, but I do need this q. So you can check your solution by distributing. If you do that, you get 6p. Distribute here, you get 15p squared. Distribute here, you get 9pq. So you know that you have it correct. This is the solution we are looking for. My next example has 8 and 17. 17 is a prime number, so they're not going to share any numbers in common. Then you have r's and s's, and so r's and s's are different bases. They share nothing in common. So this is considered to be factored already. Or you could write cannot be factored. It is prime. Either one is fine.